Hello, hello. Hello everyone, very good evening. Kindly confirm if audio video is clear. Yes, all good. Thank you. So, let's start with the second lecture of our database management series, in which we are discussing the concepts of query languages. So in yesterday's class, we have already introduced the concept of relational algebra, and we have already covered the basic relational algebra operations. So what are we going to discuss in the today's session? So let's look at this. This we will try to understand what are the derived relational algebra operation, what is intersection, what is division. Please, there are three different types of relational algebra three different types of derived relational algebra operation. One will be intersection, another will be division, and third one will be join operation. But in 1 hour time, we will not be able to complete all those three different types of operation. Therefore, in today's session, I'll just give you the introduction of intersection, and we'll basically cover the division operation of relational algebra. This is very important to understand that how exactly the division operation works and how exactly it is derived using basic relational algebra operation. Because the understanding of this division relational algebra operation will give you an intuition that how exactly you will write the query when you are trying to retrieve some specific data from the given database. Okay, so this eventually create the basis for query writing in the relational algebra. So you'll eventually understand in a while that how exactly division operation is derived and what's the beauty of division relational algebra operation. So just a quick recap. So we have already introduced that there are two types of relational algebra operation: basic relational algebra operation and derived relational algebra operation. In yesterday's class, we have already understood that what is our projection. So we will try to, if you are looking for the data from the specific columns of the relation, then you will use the projection operation. If you want to select some specific tuples satisfying the certain conditions from the relation, then you will use selection operation. Whenever you want to join the tuples of one relation with the tuples of another relation, then you will use a cross product. Then union and set difference are the set operations. This can be applied only if the relations are union compatible. What do I mean by union compatible relation? Number of attributes in both the relations must be same, and apart from that, the domain of corresponding attribute should also be same. If these two properties are satisfied, then only the set operations can be performed. Then rename operation can be used for renaming the attribute or table or both, right? So that's what we have discussed in the last class. In today's session, we are going to understand about intersection and about division operation, but this join operation will be covered in the tomorrow's class. Yeah, obviously, there is one important concept related to natural join that will be used in lossless join decomposition of the relation. So, this is important from the relational algebra point of view, from the structured query language point of view, as well as from the normalization point of view. Therefore, I was not in hurry to complete this topic in the today's session itself, because I know it is important. So it will be good if we can spend some time to understand the natural join in the join operation. Okay. So first of all, let me complete the easiest uh, derived relational algebra operation, that is intersection. Sir, how do we derive intersection? So intersection is derived using set difference. What does it mean, sir? if you want to identify that what exactly will be the tuples in R intersection S, then the tuples of R intersection S will be nothing. So let's try to understand this using the Venn diagram. So if this is your universal set, this is some relation R and this is another relation S. So this is relation R. This is S. Let's say that this is your R intersection S. So this will be your R intersection S. But please try to understand, out of this yellow color circle, if we subtract the elements which are in this purple color section, then we will be left with this white color section. So out of this yellow color circle, if we subtract the element of this purple color section, then we will be left with this with the tuples of this white color section. So what exactly this purple color section is? So this purple color section is nothing but elements of R except the elements which are present in S. So elements which are present in R but not in S. Elements which are present in R but not in S are basically the elements of R minus S. So this purple color region is nothing but R minus S. So you can actually say that R intersection S is nothing but this overall yellow color region minus this purple color region, that is R minus N and R minus S, and there you have derived your R intersection S. Yeah, so it's just a visual interpretation of R intersection S. Otherwise, it's a damn easy thing. You know that the elements or the tuples which are common in R as well as in S will be present in the output. Clear? Okay, so let's begin with the one of the most important operation of relational algebra. So it's a single operation, derived relational algebra operation. First of all, when exactly you will require the concept of when exactly you will require the concept of division relational algebra operation. So whenever your query is with respect to every or all, whenever your relational algebra query is with respect to every or all, then your mind must give you a hint that if whenever the query is asking about every or all, then you will have to use the concept of division relational algebra operation. Okay, so division will be used whenever the query is with respect to every or all. So in the last class, I gave you an homework problem. That let's assume that there are two relations. One is catalog, another is parts. We have already defined these two relations in the last class. So catalog is a relation which defines that a particular supplier with this SID has supplied a specific part with the PID at a particular cost, right? And this part table includes the PIDs of all the parts along with colors of those parts. So if I ask you that retrieve the SID, you need the SIDs. So retrieve SID of the suppliers. So these are the SIDs of the suppliers who supplied all parts. So you eventually looking for the SID of the supplier which is associated with all the PIDs of the parts table, right? So let's look at this carefully. Sir, supplier S1 has supplied part P1, supplier S1 has supplied part P2, supplier S1 has supplied part P3 as well. Therefore, this supplier ID S1 must get selected when we write the query, right? So we need to retrieve the SID of the supplier who supplied all parts. Clear? Now, if you look at S2, then it has supplied part P2, but it has not supplied P1 and P3. Please remember, supplier S2 has not supplied P1 and P3. and at the same time supplier S3 has not supplied P1 and P2. Okay, so there are some parts in the part table which are not supplied by supplier S2. There are some parts in the part table which are not supplied by supplier S3, but every part of this part table is supplied by supplier S1. So it's okay. Given a relational instance, if somebody asks you such silly thing, then it will be easy for you to answer that particular question. That given this relational instance of the catalog table and given this relational instance of the parts table, if somebody asks you that what will be the SID of the supplier who supplied all parts, right? Then definitely you will be able to say that the SID of the supplier is S1. But we are talking about a large database. So eventually, whenever you write a query to retrieve some specific data from the database, and the most important thing is that your query must be generic. What does it mean? It should not be specific to given instances of the relation. Your query must always be generic. It should not be dependent on a specific instance of the relation. Clear? Now, if I ask you that how exactly you will retrieve the SIDs of the suppliers who have supplied all parts, then ultimately we are looking for the SIDs in the catalog table. We are actually looking for the SID in the SIDs in the catalog table which are associated with all the PIDs of the part table. Getting the idea? So there are two important things in the catalog table and there is only one important thing in the part table. What are they? Sir, if you want to retrieve the SID of the supplier which is associated with all the PIDs of the parts table, then the only thing that is required from the catalog table is SID and PID, because you are only checking whether the SID is associated with all the PIDs of the part table or not. Apart from that, the information that is required from the part table is only PID, because we are not interested in the parts of a specific color. We are not interested in the parts of a specific color. Clear? So, how exactly do we determine the SIDs of the suppliers in the catalog table? How exactly we determine the SIDs of the suppliers which are associated with all the PIDs of the part table, So some of you may say that, sir, do one thing, that PID must be equals to P1 and PID must be equals to P2. That's a very general question, general answer that I get from a student, that PID must be equals to P1, PID must be equals to P2, and PID must be equals to P3. PID must be equals to P3. So in order to perform, or in order to apply this condition, the very first thing that you will have to do is what? So let's think of different solutions, right? So if I look at this catalog table and if I perform the cross product of catalog 3 times, if I cross product the catalog with itself 3 times, then this S1 P1 20, let's look at this. So this S1 P1 20 will be combined with S1 P2 30 and at the same time it will be combined with S1 P3 15. S1 P3 15. Now we know that, sir, the first part is P1, second part is P2, third part is P3. Even if they are not in the same order, then you know that S1 P3 15 will be combined with S1 P2 30 and S1 P1 20 as well. S1 P1 20 as well. So the idea is, if you perform this cross product, wait a minute, if you perform this cross product, that you say that, let's say C1 cross C2 cross C3, and then you perform a selection and then you apply a selection condition. If you say that in all this instances of C1, C2 and C3, SID must be same. You say, and C1 dot SID, if there is any tuple in which C1 dot SID is equals to C2 dot SID and C2 dot SID is equals to C3 dot SID, that's the first thing. So, sir, you don't need to check whether C1 is equals to C3 or not, because if C1 is equals to C2 and C2 is equals to C3, then C1 will be equals to C3. Then C1 will be equals to C3. If you check this two conditions, that is C1 dot SID is equals to C2 dot SID, these two are equal, and you check that C2 dot SID is equals to C3 dot SID, and if you write what, that sir, C1 dot PID must be equals to P1 and C2 dot PID must be equals to P2 and P3 dot PID must be equals to P3. If this condition is also true, then you know that you have found a tuple. In which the SID is present, which is associated with part P1 as well as part P2 as well as part P3. Therefore, from there, if you project the specific SID, then you have obtained the SID of the supplier, which is associated with all the PIDs of the part table. But this will be incorrect. If this is the solution which is in your mind, then this solution is wrong. Why? Because this specific solution is based on this specific instance of catalog table and part table. This solution is based on this specific instance of catalog table and part table. Why? Because you know that there are three parts P1, P2, P3, and you are writing the query in accordance to that particular situation, that there must be a supplier which has supplied part P1 as well as part P2 as well as part P3. But please tell me, if there are 1 lakhs, the database may be large, right? So what if there are 1 lakhs of part in this part table? If there are 1 lakhs of part in this part table, then are you going to write this condition for 1 lakh of tuples in a single query? The query writing itself is going to take 2-3 days. The query itself is going to take 2-3 days to in order to write it. Forget about execution, right? So that's the idea, that your solution cannot be specific to a given relational instance. Your solution must be generic. Your solution must be generic. So therefore, if you use this particular approach, then it will be a wrong solution. Your solution must be generic solution, that is, it can be applied on any specific data set present in the relation, and it will always produce the correct result. So let me explain that how exactly the division operation will be performed. Then in short, if I simply want to say that how exactly the SIDs of the suppliers will be retrieved, which are associated with all the parts, then I can simply say that the solution for this will be nothing. Solution for this will be nothing but from the catalog table, project the SID and PID attribute and then divide it by the PIDs present in the parts table. Come on, sir. Still not clear. So this is how you can write the division operation. But please, this is a derived relational algebra operation. This is a derived relational algebra operation. We actually need to understand that how exactly this division operation will produce the SIDs of the suppliers which are associated with all the PIDs of the part table. Clear? So that's what we'll try to understand, that how exactly this will be derived. Clear? So in the very beginning, what did I say? That the only information that is required from the catalog table is that what SIDs of the catalog table are associated with all the PIDs of the part table. You have nothing to do with the cost, that at what particular cost the supplier supplied that part. It is not important. At the same time, we are looking for the SIDs which are associated with all the PIDs of the part table. So the only two things, so you can actually see that how exactly this division, how exactly the relational algebra query using the division operation is written, right? So you are only taking the SIDs and PIDs from the catalog table because those are the only two attributes which are required in order to provide the solution of this query. And from the parts table, we are only interested in the IDs of the part because these are the only different values with respect to which we are checking whether any SID is associated with all these PIDs or not. Right? So these are the only two attributes from the catalog which are required for the for answering the above query or for answering the above question. And from the parts table, the only attribute that is required is PID. Okay. Now let's try to understand how exactly this thing will work. Further, let's just 1 minute. Come on. So on this two specific relational table, first of all, we are trying to derive the division operation. So please don't directly look for the solutions. I know that many of you may want to crumble the formulas for the division relational algebra operation. But if you are cramming something, then you are not learning anything. If at all you want to answer some difficult questions that has been asked in the GATE exam, then you must understand the process, that how exactly that particular thing is done. And that's what I'm trying to explain. I'm not here to give you the formula for division. I'm going to give you an intuition that how exactly the division operation is derived and how exactly it will provide the SIDs of the suppliers which are associated with all the PIDs of the part table. Clear? So here, I mean, the basic concept that you must have in your mind is that, sir, there is no way, there is no direct way to check whether any SID is associated with all the PIDs of the part table or not until we write a selection condition in which all the PIDs of the part tables are present. But again, that particular query will be specific to a given instance. Therefore, we will try to do something else. What's up? So let me first write something that if from the catalog table, if I project SID from the catalog table, if I project SID, then what am I going to get? So from the catalog table, if I project the SIDs, then I'll get the SIDs of the suppliers who have supplied some parts. I don't know how many parts of what type, but if at all an SID is present in the catalog table, then that particular supplier must have supplied some parts. So in the output, you will get S1, S2 and S3. Obviously. Why? Because the relational algebra query will always produce distinct tuples. So that's one thing. Another thing is, so what is it? Sir, these are the SIDs of the suppliers who have supplied some parts. Just 1 minute. You will understand it in a while. Now, if I write another query in which I simply project the PIDs of the different parts from the part table, then the output will contain all the different PIDs in the part table. So there will be three PIDs, P1, P2, P3. So these are the different PIDs in part table. Oh. Now, the important concept is that if at all I perform the cross product of these two things, so what this catalog table, if SIDs are projected, you will have S1, S2, S3. Just a minute, you will get the idea. So this is S1, S2, S3. From the parts table, if you have projected PID, you will get P1, P2, P3. Oh. Come on, sir. So these are the SIDs that we already know. These are the PIDs that we already know. Now my question is, if I perform the cross product of these two relation, if I perform the cross product of these two relation, what will happen? S1 will be associated with all the PIDs present in the part table. Similarly, S2 will be associated with all the PIDs present in the part table, and S3 will also be associated with all the PIDs present in the part table. So the output of this will be nothing but you will have a relation in which every SID present in the catalog table is associated with all the PIDs in the part table. So here you will get SID and PID. So what will happen? So this S1 will be associated with P1. This S1 will be associated with P2. S1 will be associated with P3. Similarly, S2 will be associated with P1. S2 will be associated with P2. S2 will be associated with P3. Similarly, S3. That's what we do in the cross product. Every tuple of first relation will be combined with every tuple of the second relation. So that's okay, that this is how the cross product will look like. But what information is present in this set? So it is a universal set. It is actually the universal set. So what do I mean by universal set? It is a universal set. What is happening here? Every SID present in the catalog table is associated with every PID present in the part table. So it is a universal set in which every SID present in the catalog table is associated with every PID of part table. Now, the important things that you need to understand is that, sir, in the original relation, we have the information that a particular supplier has supplied what parts. In the original catalog relation, we have the information that which supplier has supplied which specific part. So this is the actual information, and this is the universal set. Now what is happening in this universal set? So in this universal set, every supplier is supplying every part. In this cross product, every supplier in the catalog table is supposed to be supplying every part of the part table. Now the next thing that you must understand is that what happens if whatever this output is, please try to understand this. F cross product with the PID of parts table, then this is your universal set. Right? So out of this universal set where every supplier is supplying every part, if we subtract the actual information, that is from the catalog table, look at this is very important. From the catalog table, if we select the or if we project the information related to SID and PID, if we project the information related to SID and PID, what will you get? So this is the universal set. Just 1 minute. You already have this table. Now, sir, what is the actual information? Supplier ID and part ID supplied by that particular supplier. So I know S1 has supplied P1, S1 has supplied P2, and S1 has supplied P3. Apart from that, S2 has supplied P2, S3, P3. Come on. There are various things that you will understand. In this cross product, we have every supplier of the catalog table supplying every part, that is S1 P1, S1 P2, S1 P3, S2 P1, S2 P2, S2 P3, S3 P1, S3 P2, S3 P3. Now the idea is, sir, after this subtraction, what will be the result of this subtraction? After this subtraction, if you subtract the actual information present in the catalog table, if you subtract the actual information present in the catalog table from the universal set, so what are you actually trying to do? Sir, in this set, every supplier supplied every part, and here we have the actual supply information, that which particular supplier has supplied what set of parts, right? So if at all, listen to me carefully, if at all there is any supplier in the catalog table, if at all there is any supplier in the catalog table that has supplied all the parts of the part table, then after this subtraction, the information about that particular supplier will be eliminated completely. Yes or no? So you can actually see, sir, S1 is associated with P1. Here also S1 is associated with P1. Therefore, after subtraction, S1 P1 will not be available. S1 is associated with P2. S1 is associated with P2. Therefore, after subtraction, S1 P2 will not be available. S1 is associated with P3. Here also S1 is associated with P3. So S1 P3 will not be available. So if at all there is any supplier that has supplied or who has supplied every part of the part table, then after that subtraction, the information of that particular supplier will vanish, right? So you will be left with what? Come on, that's the idea. Sir, after this subtraction, you will be left with the SID of a supplier who has not supplied all the parts, and along with that SID, you will get the information about part ID of the part that has not been supplied by that particular supplier. So come on, sir, S1 has supplied all parts, so there is no part that is not been supplied by the supplier S1. Therefore, there will be no tuple related to supplier S1. Now, S2 has supplied part P2. So the information about this S2 P2 will be subtracted, and the information S2 P1 and S2 P3 related to supplier S2 will remain after this subtraction. So you will have S2P1 and S2P3. So please try to understand, your supplier S2 has not supplied these two parts. S2 has supplied P2. S2 has supplied P2, but S2 did not supply P1. S2 did not supply P3. Yes or no? So these are the two parts in the part table which are not supplied by the supplier S2. Similarly, S3 is associated with P1, but here S3 is not associated with P1. So after this subtraction, S3 P1 will remain. S3 is associated with P2. Here S3 is not associated with P2. So S3 P2 will also remain. But here S3 is associated with P3 in the universal set, as well as it is S3 is associated with P3 in the original set. So after this subtraction, the S3 P3 will not be available. So what exactly did you receive after this subtraction? So it contains the information about the suppliers who did not supply all the parts, along with the PIDs of the parts not supplied by them. Clear? So what does it contain? It contains the tuple it contains SIDs of the suppliers along with the PIDs of the parts that are not supplied by them. Clear? So here, when every supplier supply every part, here we have the actual information, actual supply information, that who has supplied what set of parts. After this subtraction, you will be left with the tuples in which you will have the supplier ID and part ID, such that you will have the tuples, you will have the information that a particular supplier, what are the parts which are not supplied by a particular supplier. Clear? So, sir, in the output of this subtraction operation, in the output of this subtraction operation, we have the information about the suppliers who did not supply all parts, right? So, if at all I project the SID from the output of this subtraction, if at all I project the SID from the output of this subtraction, then you will get two SIDs. One will be S2 and S3. S2 and S3. So these are basically the SIDs of the suppliers who did not supply all parts, right? So if supplier S1 has supplied all the parts, then after this subtraction, the information about supplier S1 will completely vanish, and you will be left only with the information about the suppliers who did not supply all the parts. So if you project the SIDs from the result of this subtraction operation, then you will get the SIDs of the suppliers who did not supply all parts. So now this is the SID, these are the SIDs of the suppliers who did not supply all parts. No matter, please look at this. Did we use any information related to P1, P2, P3 or S1, S2, S3 while writing this query? No, sir. So this is a generic query. No matter what are the tuples present in the catalog table, and no matter what are the tuples present in the part table, if you do so, then after this series of operation, in the end, we will get the SIDs of the suppliers who did not supply all parts. So there is at least one part which is not supplied by that particular supplier, then only that particular supplier will be present in the output of this subtraction operation. Now, the last thing that you need to do is, we know that from the catalog table, we have already projected SIDs. So, these are the SIDs of the suppliers. So, here we have S1, S2, S3, right? S1, S2, S3. So, these are basically nothing but SIDs of the suppliers So SIDs of the suppliers who supplied some parts. So here are the SIDs of the suppliers who have supplied at least one part. Maybe all, but these suppliers have supplied at least one part. So out of these suppliers who have supplied some parts, out of them, if we subtract those suppliers who have not supplied all parts, then we will be left with the SIDs of the suppliers who have supplied all parts. Yes or no? Then we'll be left with the SIDs of the suppliers who have supplied all parts. So in the end, if I perform this subtraction operation, then the output of this subtraction operation will be S1, and ultimately SIDs of the suppliers who supplied some part minus SIDs of the suppliers who did not supply all part will be SIDs of the suppliers who supplied all parts. Got the idea? So we were interested in identifying the SIDs of the suppliers who supplied all parts, but there is no direct way. There is no direct way to write a single query so that you can get the SIDs of the suppliers who have supplied all parts. If you write a query which contains all the different PIDs present in the part table, then the very first thing is that that particular query will not be a generic query. Why? As the entries in the part table changes, you will have to change that query as well. Yes or no? So as of now, let's say assume three parts P1, P2, P3 are present in the relation. So if any new part is added in the relation, then also you will have to change the query. If any existing part is deleted from the part table, then also you will have to change the query. If the ID of a part is changed, then also you will have to rewrite the query. That means if any change occur in the part table, then you will have to rewrite the query, and if the database is too large, then the query writing itself may take too much amount of time. Clear? So that's the idea. Whenever we are writing a query to retrieve any specific information from the database, please make sure that your query is a generic query. Otherwise, that query will be considered wrong, no matter what. If your query is not a generic query, that is the query that can be applied on all the different types of instances of the relation, then the given query will be considered, or the written query will be considered wrong. Make sense? Clear? So that's the idea. So once we perform this subtraction, after this subtraction, whatever you are going to get will be the SIDs of all the suppliers I know that if you have in this particular format, then whenever you want to revise, you will be able to revise this specific concept. Now, another thing that you have learned is what happens if you try to trace this query while reading this query from left to right. Come on. If you read this query from left to right, are you going to understand this query? Given a relational algebra query or whatever, okay? Given a relational algebra query, if you try to interpret that query while reading from left to right, that will be the biggest mistake of your life. You will not, most of the time, you will not be able to understand that what exactly is being produced by that particular query, right? In order to understand that what output will be produced by a given query, you must understand that what is the order in which that particular query will execute. Before you understand that what will be the output that will be produced by a given query, the first thing that you need to understand is in what order that particular query will execute. So, it is very important to understand the order of execution. So, what will be the order of execution for this particular query? Sir, this one is an standalone query. Therefore, the very first thing that will be executed is this. Huh? So that's the first thing that will execute. Then when you have executed this, until this particular set of SIDs are available, you cannot read anything. So the next thing that will execute is, first of all, you will compute this cross product. Then until you subtract this specific information from this universal set, you will not be able to understand that what exactly is being produced. So that will be the third thing that will be performed. Then you will obtain the result of this subtraction. So you'll see, okay, so these are some SIDs. So these are SIDs present in the catalog table. That is, these are the SIDs of the suppliers who have supplied. These are the SIDs of the suppliers who have supplied some parts. So it's okay. So these are the SIDs of the suppliers who have supplied some parts. Then you move ahead. You'll say, you are projecting all the SIDs from the catalog table, you are projecting all the PIDs from the part table, then you are performing the cross product. Means you are combining all the SIDs in the catalog table with all the PIDs in the part table, means you are creating a relation in which every supplier has supplied every part. Come on. So there is a universal relation. And once you understand this basic concept, you will know that, okay, every supplier has supplied every part. So from that relation in which every supplier has supplied every part, you are trying to subtract the relation, you are trying to subtract the information present in the actual catalog table. So basically you are subtracting the information that who has actually supplied for what parts, who has actually supplied what set of parts. So after the subtraction, you must understand that if there is any supplier who has supplied all parts, so in the LHS also, there in the LHS, every supplier has supplied all parts. In the LHS of the subtraction, every supplier has supplied all parts. In the RHS, if there is any supplier who has supplied all parts, then the information related to that particular supplier will completely vanish, and we will only get the tuples corresponding to the suppliers who have not supplied all the parts. So then you will understand that, okay, this subtraction will contain the SIDs of the suppliers along with the PIDs of the parts which are not supplied by those suppliers. Now, from this set, if you project this SIDs, then you will come to know that, we are actually projecting the SIDs of the suppliers who have not supplied all parts. Okay. So SIDs of the suppliers who have supplied some parts minus SIDs of the suppliers who have not supplied all parts will give you the answer that the SIDs of the suppliers who have supplied all parts. SIDs of the suppliers who have supplied all parts. So please don't try to interpret a relational algebra query from left to right. Try to understand the order of execution. Order of execution will be defined by these brackets. Okay, so order of execution will be categorically defined by this brackets, otherwise left to right. So don't try to interpret a query, relational algebra query from left to right. Please try to understand that in what order the given query is going to execute, and that will give you the idea that what value will be produced by the execution of that particular query. So now, if I just define the division operation, come on, let's look at this. Sir, in the catalog table, there are various attributes. Come on, let's look at this. In the catalog table, we have attribute SID, we have attribute PID, we have attribute cost, right? In the parts table, we have information PID and we have information color. Please try to understand that when you are writing the division, that is retrieve, again I am writing the same query but to explain something. Retrieve SIDs of the suppliers or supplied all parts. So the very first thing that you must understand is, can I write so? Please, if I simply write catalog divide by parts, it will be wrong. If you simply write catalog divide by parts, it will be wrong. So please don't do that. Please don't do that. First of all, you will have to identify that what specific informations are needed from the catalog table and what specific informations are needed from the part table. So you must understand that the only, so let me write it again, that catalog divide by parts, this will be wrong. Clear? So in order to get this information, you must write that what are the informations which are needed from the catalog table. So what are we looking at? Sir, we are looking at that the SIDs which are associated with, SIDs will be required, which are associated with what? Sir, PIDs of all parts, PIDs of all parts. So two things will be needed, SID, PID. Now, sir, you need the SIDs which are associated with all the PIDs. Associated with what? Sir, with PIDs of what? Sir, of parts table. So this is what you are writing, and this division operation. This division operation is derived as I explained that first of all you will perform the cross product of this two. Just a repetition of concept, but that's fine. I'm not going to write the complete thing. So first of all, you will perform this. Then you will project SID and PID from catalog. Second thing, then you will subtract this two. And from that subtraction, you will project SID so that you will get the SIDs of all the suppliers who have supplied, who did not supply all the parts. Then you will have the SIDs of the suppliers who have supplied some parts. So the suppliers who have supplied some parts, from that if you subtract the supplier who did not supply all parts, then you will get your answer. So this is how it will be derived. This is how it will be derived. It will not be a single step operation that you simply write this and it will happen in a single go. No. Internally, if you write this also, then it will be a valid syntax. It will be a valid syntax with respect to relational algebra. But when you write it internally, this is what will happen. Internally, this is what will happen in the system. I hope every concept is clear associated with division operation, and this is a very important concept because if you do not understand the division operation, then you do not understand most of the concept of relational algebra. Clear? So we have discussed the division operation in complete detail. Similarly, in the tomorrow's session, I am going to discuss this natural join operation in complete detail, because this is the most important thing. Every other thing is damn easy. So the explanation of every other thing will require maximum 10 minutes. The explanation of these three different types of join operation will require maximum 10 minutes, but the discussion of natural join will require enough amount of time. So, I mean, we'll try to cover it within the given duration of 1 hour. But yeah, this is an important concept, because this will be required in the relational algebra as well as in the structured query language as well as in the normalization. Yeah, but some silly questions can be asked related to concept of outer join, which will not require more than 30 seconds to answer if you already know the concept. So we have discussed some derived relational algebra operation, that is intersection and division. There should not be any doubt in your mind related to division operation. If you have any doubt, you can write those doubts in the comment, or you can send me your doubts. You can send your doubts via Telegram channel. So you can simply search Vishal Raotia, Vishal Sir PW, not even Raotia, Vishal Sir PW, and you will be able to find my Telegram group. So that's it. Thank you very much for joining the session. I hope you like the session and you have understood the concept of division operation in complete detail. Thank you very much. Once again, good night. Take care. Keep learning.